Let's try another example. So here we have the equation x squared times y raised to the power 6 equal to 1. And we want to calculate the derivative dy dx. So again, we're viewing y as a function of x. But now we don't actually have a formula for what y is equal to. We just have this equation. So we're viewing y as an implicitly defined function. So we're thinking of wherever we see a y here, we're thinking of there being some hidden x terms hidden inside of it. All right, so we're going to use this implicit differentiation technique. So first step, apply the derivative to the equation. So let's write down our equation. X squared y to the 6 is equal to 1. And we're going to apply the derivative to both sides of this equation. Now we have multiplication here. So it's not like the last example where there was addition in between these two x's and y terms. Here we have multiplication. And so the derivative doesn't break up so nicely over multiplication. And so what we have here is we have one term here on the left, and this term involves both x and y. So that means we have to use some of our more advanced derivative techniques or derivative rules. And the fact that we have a product here, we have x squared times y to the power 6, we have a product, means we need to use product rule here. So if it was a quotient, then you might have to use quotient rule. If it was like a composition, well, then you might have to use chain rule. But we have multiplication right here in the middle, so we have to use product rule. So let's see how this is going to look. So we write down two copies of our product, x squared times y to the power 6, x squared times y to the power 6. In the first copy, we apply the derivative to just that first term. In the second copy, we apply the derivative to just that second term. And then we put a plus sign in the middle. So that's product rule. What about on the right side of our equation? We're differentiating the constant 1. Derivative of a constant is just 0. So we just get a 0 over there. So this was product rule, what we did here. And now what we've done is we still have some derivatives to do, but now each of these are things we can handle. So things that we've seen before. So derivative of x squared. This is a term involving only x. And if we look over here, we still have to do this derivative of y to the power 6, but now we're only differentiating a y term. All right, so we have this only an x term to deal with here. We have this only a y term to deal with here. And we kind of saw what to do in the last example. So we're going to differentiate this x squared just like we normally would. So derivative of x squared is 2x. And then the y to the power 6 is outside the brackets, so we don't do anything there. And it's a product. Then we go on, we have plus x squared. That's outside the brackets, so we don't do anything to it. And now we want to differentiate this y to the power 6. So again, we're using implicit differentiation. We're viewing y as a function of x. So we're going to start by differentiating that y term just like usual. So 6 y to the power 5. But then we differentiated a y term here, so we multiply by y prime. And then this is going to be equal to 0. All right, so now we're done with the differentiation. So that's kind of step 1 here in our list. The rest of this is just solving for y prime. So sometimes that's the hardest part. And so what we want to do is we want to go through and identify all the pieces of our equation here that have a y prime. So I see a y prime right here. And then anything that doesn't have a y prime, I'm going to move to the other side. So when I look at this, This 2x times y to the power 6, there's no y prime there. Get it out of there, move it to the other side of the equation. And here I do see a y prime. So I'm going to keep this whole thing. I'm going to keep this whole thing on the left side. So I'm going to have 6x squared y to the power 5 times y prime on the left. And it helps to just kind of reorganize things. So put the constant first, and then probably go in alphabetical order. So x squared y to the power 5. And then put y prime on the very end. And then I've moved this 2x times y to the power 6 over to the other side. So really what I'm doing here is I'm subtracting it from both sides of the equation. So when I move it over to the right side, it actually becomes negative. So I'm going to have a negative 2x y to the power 6. And I want to keep solving for y prime. So really I want y prime all by itself. So this other stuff over here on the left, I'm going to divide by it. So I'm going to divide both sides by 6x squared y to the power 5. And so when I do that, I get y prime all by itself on the left. All these variables and constants are going to end up canceling. So I'm going to be left with just y prime. And then on the right side, I have this fraction right here, which I could simplify down if I wanted to. So there's some terms that I could cancel out of here. So for instance, I have a 2 and then a 6. That simplifies to just 1 over 3. Then I have 1x on the top and 2 x's on the bottom, so I could cancel out an x from both of those. And then here I have 6 y's on the top and 5 y's on the bottom, so I could cancel out 5 of the y terms. So I'm left with just a y on the top. So if we simplify this down, we end up with negative y over 3x. So again, not absolutely necessary to simplify things down like this, but it can be helpful. So we end up with our derivative y prime is negative y over 3x. And so we've used this implicit differentiation technique. And really, this example is showing us what to do if we have a term involving both x's and y's. Here we had to use product rule because it was actually a product. All right, so we're just going to look at a few more of these just for that practice. So we'll see you there.